So we're going to do the next one here, number 11. It uses the same formula that we had talked about earlier. We have the answer that we're looking for, the principal or that starting value, 1 plus the rate as a percentage over the number of times per year that's computed, and then the number of times per year times the years are multiplied as a power. So the answer to this is going to be 650,000 is our starting number. 1 plus the rate. The rate is 3.4%, so notice how it's written, 0.034, over the number of times per year, and it's just once, because it doesn't really state anything where it says each year, so it's 1. And then 1 times t. Now we don't know what t is, because they ask us how many years will it take for the population to double, and so we're going to have to use our calculator here. So let me get the calculator out, and then let's work with that. Here, just a second here. Let me grab this. Okay, so here's the calculator, and we want to double the population. Well, the current population is 650,000, so 650,000. So it's 1, 2, 3 times 2. So we're looking for 1.3 million. So that's what we want. We want 1.3 million. So 1.3 million, or this right there. That's what we want. And so we're just going to kind of guess and check right now. That's what we're going to do. So we're going to pick a number for t and try it. So a really easy number for t is like 10 or 15 or 20. So let's just do 15 years and see what happens. So I'm going to put this in the calculator. Again, when I write this in the calculator, I'm going to write it like this. 1 plus, and then the fraction is going to go in its own set of parentheses. Just a sec, I got to erase that. Here. Divided by 1. Notice there's 2 parentheses in a row, and then the power is going to go right here. So it'll be 1 times 15. And I'm going to try that out and see what happens. Okay? So I put in the calculator. I tried 15 for t, because we don't know. We're just trying to find what value will be t. So we tried 15, and it didn't work. So we're going to pick a new number. So we'll pick, like, I don't know, 17 or 18, and then find it out. So let's do that. I'm going to pick a new number. We're going to try it. So let's pick, let's see here. Let's pick, let me think. Let's pick 20. Let's try it with 20 and see what happens. So I tried 20 and I got almost what we need. We're only off by a few numbers here. So because I tried 20, I know that the t value is going to be 20 to 21 years, because we got pretty close. So it'll probably end up being like 20.7 years or something, or almost 21 years, because we got pretty close. So on this problem, just kind of guess and check using your calculator until you find it. Or you can, see if you can make a graph of this and look at a graph. That helps. The depreciation one is a lot easier and a lot quicker to do. So we have our depreciation formula, or a decay formula, where we have our initial amount, and it's going to be 1 minus the rate to the t. And that's a lot easier to put in the calculator, a lot less parentheses here. So our answer is going to be what we took. We took 3 pills, or 600 milligrams, and we're going to subtract our decimal. Now notice it's 29, so it's 0.29. That's a little trick there. Is if it's a single digit, you have these extra zeros. This doesn't have an extra zero because it's 29%. And we have 4 hours. And then we're going to put that in the calculator. I can put that in the calculator exactly how that is written, actually, and then have an answer here. So this one isn't that difficult. The decay ones I think I like a lot better, because it's a lot easier to do them. So 600 parenthesis 1 minus 0.29 for 29% to the power of 4. And then after 4 hours, we still have 152 milligrams left in our body. Okay, and that's what's I really hope you understand. It says you can take ibuprofen every 4 hours. We actually still have almost a whole pill of ibuprofen in you at 4 hours. That's why they say you can't exceed so many doses in a day, because the residual happens each time you take a dose. So by the time you take 4 doses in a row, you actually have like double the amount of ibuprofen in your body. That's why they say you can't have more than 12 pills in 24 hours, because it turns out 4 hours you still have a whole bunch left in your system. So we learned something today, I guess. The last one is the value of a new car is reduced by 15.5% per year. Find the value of your dream car after 4 years. So you can actually go online and find a car that you want to purchase and then use this formula. I know for me and my family, we're looking at purchasing like a Chevy Transverse or something like that. They're priced around $35,000. So the answer we're looking for is going to be $35,000. And then it depreciates at 15.5%. So that's going to be 0.155. And then we're going to have it for 4 years. And so I'm going to put that in the calculator, hit enter, and then I'll find out the value of my Chevy Transverse after I drive it around for 4 years. And then you can see how much money we lose in that time. So 35,000 parenthesis 1 minus 0.155 close parenthesis to the power of 4. Enter. 17,844 and 11 cents. So 17,844 and 11 cents. Okay, so we actually lose half the value of our car in 4 years. So we actually lost about $17,000 in 4 years by buying a brand new car. And that's because this number is large, right? If I bought it here, if I bought a 4-year-old car and kept it for 4 years, it'd probably cut the value in half again. So if I bought a used car, I only lose $8,000 in 4 years. So the cheaper the car that you buy, the less money you lose over time. To the point where if you buy a car that's like $1,000 in 4 years, it's still going to be worth almost $1,000. So